Today we're talking about relations and functions. A relation is a mapping or pairing of input values with output values, and it's any pairing of basically x's and y's. So remember, inputs are the x's, outputs are the y's. A relation can be shown as a list of ordered pairs, as a mapping diagram, as a graph, as a table of values. Any way that you are connecting x's and y's together is a relation. The domain is the set of input values, the x's. The range is the set of output values, the y's. A function is a special kind of relation where there's exactly one output, so one y value, for each input, for each x value. So I'm going to put two relations down here. Relation A consists of the ordered pairs 2, 3, and 4, 7. Relation B has the ordered pairs 2, 3, and 2, 7. Relation A is considered to be a function. The x value 2 only has one y value 3. The x value 4 only has one y value 7. The relation B is not a function because the x value 2 has two potential y values. It has the y value of 3, it also has the y value of 7. So the key here is if you have a repeated x value, an x value that's used more than once, it is not a function. In the process of cleaning up these notes from last year, I fixed a lot of the problems with these notes, but I also created a few new problems. So I forgot to draw in the arrows prior to copying these notes. So please draw these arrows in for me in your notes. Number 2 is a little bit crazy. This first mapping diagram is another way to express the ordered pairs -2, 5, -1, 6, 0, 7, and 0, 8. A mapping diagram links the x values, the input, to the y values, the output. So mapping diagrams are actually really nice if you're asked to identify the domain and range, because basically the first column is the domain and the second column is the range. So the domain is -2, -1, 0. The range, 5, 6, 7, 8. When you write your domain and range, you need to write them in numerical order. And if there happens to be any repeated values, you don't write the repeated values. So if you just look at the ordered pairs, you see that 0 happens twice in the x values. You don't write that 0 twice in the domain. Now, is this mapping diagram representative of a function or not? This is not a function, because of this part right here. The x value 0 has two potential y values, and each x value can only have one y value. So in number 2, I'm going to get you started on the ordered pairs. The ordered pairs would be 5, what's the second part of that point? 5, 1. Write the ordered pairs. Identify the domain and range, and then decide if it is a function or not. The domain is 5, 9, 11, 12. The range is 0, 1, 7. Is this one a function? Yes. The 5 only goes to the 1, the 9 only goes to the 7, the 11 only goes to the 0, the 12 only goes to 7. Having repeated y values is totally fine as long as you don't have repeated x values. So really the key is if you have repeated x values, it is not a function. I really like using this kind of a graph because the origin isn't actually shown on this graph, so you can use whichever crosshair you want as the origin. So typically we use the middle as the origin, and if you're a little bit lazy and don't draw in your x and y axis, that is fine. However, I am going to draw mine in. Just a reminder, when you're graphing points, the first number is the x, so that tells you how far you move side to side. The second number is the y, that tells you how far you move up or down on the y-axis. So just remember, when you're graphing ordered pairs, right or left first, then up or down. So graph these 4 points, identify the domain and range, and then we'll talk about if it's a function or not. The domain needs to be the x values in numerical order from smallest to largest. So our smallest x value is -1, and then 0, 1, 2. So you can either look at the ordered pairs to get that, or if you want to look at the graph, here's the point that's the farthest to the left, and that's an x value of -1, and then you can move to the right from there. Your range needs to be your y values from smallest to largest, so -4, then 1, 5, 7. Is this a function? Yes, there are no repeated x values, so yes, this is a function. Now, what happens if I add the ordered pair 1, 5? Seriously, computer. When I add that purple point, is it still a function? Because the x value 1 could have a y value of 5, or the x value of 1 could have a y value of -4. And if you look on the graph, do you see how those 2 points are on a vertical line? A vertical line would connect those 2 points. Do you guys remember something called the vertical line test? What the vertical line test does is it checks to see if there's a repeated x value. Because if there's a repeated x value of 1, a vertical line at 1 would hit both of those points. So turn the page, and this will lead us directly into the vertical line test. A relation is a function if and only if no vertical line intersects the graph of the relation at more than one point. So if you draw a whole bunch of vertical lines through this graph, each vertical line can only touch the graph at one point. So this first one, is this a function? Yes. Vertical lines only hit one point at a time. The next one, is it a function? Yes. Even if it's super steep, a vertical line would still only hit one point at a time. How about the third one? No. If you put a vertical line in here, it hits the graph in 2 places. That means there's a repeated x value, and it is not a function. Okay, the next one. Graph the relation, then tell whether the relation is a function. So again, just practicing. Another way to show a relation is through a table of values. Graph these points from the table of values and then determine if it's a function. Now, if you were to write the domain and range, the domain would be this top row. -5, -4, -3, 0, 3, 4, 5. The range would simply be this first part. -6, -4, -2, -1. You don't write the repetitions when you're writing the domain and range. So just a reminder, don't write repetitions. Write them in numerical order, no repetitions. Okay, graphing equations in 2 variables. Hopefully this is a super easy review. I do want to remind you that when in doubt, you can always graph using a table of values. Pick a couple of x values. You can pick whatever you want. I like -2, 0, and 2. And plug those x values in to get the corresponding y values. So if we plug in -2, 2 times -2 is -4, -4 plus 1 is -3, Plug in 0, we would get 1. Plug in 2, we'd get 5. How many of you right now are thinking you could just graph like y equals mx plus b? Anyone thinking that? Yeah. So if you remember y equals mx plus b, b is where you begin on the y-axis, that's the y-intercept, and m is how you move, that is your slope. So I'm going to graph this both ways, using the points -2, -3, 0, 1, and 2, 5. Or start at 1 on the y-axis. Your slope is 2, so up 2 over 1. Okay, here's my note at this point. If you're looking at how I just put that on the graph and thinking, I don't understand either of the ways that she put that on the graph, you need to come see me. It is perfectly fine. If you have struggled with graphing forever, that is fine. I can help you if you come and see me. So if your graph does not look like that, or you don't know how I got that on the graph, please come see me. Before school, after school, Wildcat Hour, whatever. I'll spend 5 minutes with you helping you graph, and you'll feel so much more confident after that. Number 4, y equals -x. You're basically taking your x values and taking the opposite of them. Or you're starting at 0, your y-intercept is 0, your slope is -1. My lines might not be perfectly straight because there's really just no way to do straight lines on this computer. But notice I'm putting arrowheads on the ends of the lines. Please make sure you're putting arrowheads. Y equals 2. Notice there's no x in that equation. When all you have is y equals a number, it is a horizontal line, and your slope is 0. So, hoi, horizontal line, 0 slope, y equals. If you were to do the table of values, this is actually kind of interesting to look at. If your x is -2, your y is 2, because it says y equals 2. If your x is 0, your y is 2. If your x is 2, your y is 2. If your x is 1074, what would your y be? 2. Your y is always 2. So all of these points lie on a horizontal line that crosses at 2 on the y-axis. Every single point on that line has a y value of 2. If we looked at, let's say x equals 4. Vux is for vertical lines. X equals a number gives you a vertical line with undefined slope. So if we do x equals 4, that would be this vertical line that I'm drawing in purple. A linear function is a function that can be written in the form y equals mx plus b. The important thing here is that it's a plain, ordinary x. Not x squared, not x to the third, not x as an exponent, not x on the bottom, just plain, ordinary x. So take a look at number 8. Is number 8 a linear function? 2x plus 3. Yes, that is linear. What does this f thingy mean? This says f of x. It's a fancy way of saying y equals. That's all it is. It's a fancy way of saying y equals. Next, they want us to evaluate this function for the given value of x. They want us to do f of -7. F of -7 means take f, plug -7 into it, and see what you get. So 2 times -7 plus 3. That'd be -14 plus 3. You want to write your answer as f of -7 equals -11. This is why math people like function notation, because it shows you both the input and the output all in the same statement. The reason mathematicians love function notation is because of the amount of information it gives you. It tells you which function we plugged a number into, what the input was, and what the output was.